Good afternoon. It is January 23rd, 2024. I have slowed this down, this view of the sun, super slow. And what I want you to look at is how the bright spots on the sun are moving between the different sunspot groups and within the different sunspots groups. And so short, I want you to watch how the bright spots move around the loops and between the filament lines. You see it's moving around the loops. The energy is moving around the loops, but it's also moving over here, down, up and down the filament lines between the groups. They talk to each other, in short. And it's important to realize that the whole sun is electromagnetically charged. And this electromagnetic energy is what runs our universe. It's a very important key component we need to understand. So let's look at an important part of this. And I'm going to bring this back. And again, this is slowed way down. You're looking at this loop right here. You see, this is a filament line. Here is one of our filaments, and you can see the energy building. This is starting to lift off from the sun, bigger and bigger, and you can see that and how it gets puffier and puffier. And there's more plasma getting sucked up in here. You can see it getting sucked up right in this area right here as it grows. And it's getting puffier and puffier, and there's more and more getting sucked up in this as it lifts up. And right here, it breaks away. Whap! There goes our CME. And everything forms right back down and gets pulled right back down into those loops. And that is called a magnetic reconnection. Oh. So what I want to do, and I've got to go back and find, this is called a magnetic reconnection. And we're looking right here at a diagram of that filament. Okay, here's our sun. Here is that filament line. And you notice the arrows go one way. They all go one way. And then you notice all the way around that, there's all these squiggly little things running around it. And they're like a slinky. They run around that magnetic field line. That is your plasma. That is your supercharged electrons from the electromagnetic energy. And they're all tethered and confined to that magnetic field line. And that filament line, that magnetic loop. Once that loop reaches high enough off the sun, it's going to break. And when it breaks, it allows everything to stream off that magnetic field line and pushes it in a major explosion out into space. And that is a CME, a coronal mass ejection. It is an explosion that pushes all that material that's around that magnetic field line, all that plasma and the electrons and all that stuff, it gets pushed out into space. And that is what causes our auroras. But when it's done, after that explosion, the ends of that magnetic field line snap back together. And that is where you saw it leave, and then you saw it form right back into a loop. Okay, now, let me find it here. I'm going to use this one because this is a good one. We have that on Earth too. And this isn't the best diagram. Let me see if I can find my better diagram. Where is my better diagram here? Oh, there it is. Okay, so here is our Earth. Our auroras are coming along here. All the space particles, they're running into our magnetosphere, which is here. Some of them get to bounce into our poles. They find the weak spot and they come into our poles, and that causes our auroras. Some of them get pushed along the field lines around the magnetosphere, and they get pulled into this plasma sheet at the back, the tail, behind our Earth. And you can see how it's stretching, and eventually, just like on the sun, it will break. Part of that will break off into space. Part of that will break off and get hurled right back down the magnetic field lines into our polar regions. And this creates what we call another magnetic reconnection. This will cause a secondary spike in the auroras. You know, we often see we get a real big spike in the beginning, and then a couple hours later, we get another big spike. That's what causes it, is this magnetic reconnection. And that magnetic reconnection has enough energy in it to power the entire United States for 4 days. And you think of how much power and energy the United States uses in 4 days. That's how much energy is out there. There's actually satellite, you can look this up. It's the MMS satellites are up there monitoring these magnetic reconnections. They're dish satellites with great big arms the size of football fields that are monitoring these magnetic reconnections and studying them, and they're trying to figure out how we can harness that energy someday. And it's actually a really interesting study, and you should look it up. Okay, so okay, we don't need that. Okay, going on. So we're going to look at our differentials. Now, your red is the satellite that's off to our left. It's on our incoming limb. Blue is coming right at us. And I'm going to pause this just for the minute. I'm going to put it right at the beginning. Now, the blue, we're right behind the center disk. So whatever's coming around that center disk is going to hit us. Whatever's going off one side or the other is going to miss us. But if it's all the way around the halo, or 3/4 around the halo, it's telling you it's going to be a direct hit. This over here is a highly defined view of what's over here. It's highly detailed, so we can really get in there and see just how much plasma, just how dense things are, just how fast they're moving. So as I put this into play, and I may stop it and run it backwards at points, you can see what's going on. Okay, this is probably going to be a miss, but there's a little bit coming all the way around the disk. It's going to be a bit of a brush. Here is a full halo hit. You got stuff moving all the way around, and it continues to move all the way around, but it's not moving particularly fast. So we've got a good big break. It's still streaming out somewhat slowly, but we're still getting full halos. Now here's our big one right there. And I'm going to pause it for a minute, and I'm going to roll this backwards. Now I posted this morning, and Suspicious Observer was saying it's going to be a complete miss. As this comes out, yes, it is being directed down and away. The bulk of it will miss us, and thank God it did, because this is super dense and it's moving quite fast, and you don't want to be in front of that thing. This would cause all sorts of damage, from satellite damage, electrical grids, power grids, GPS, satellites. Everything could get damaged from this. It would cause heart issues, mental health issues. People with migraines would be suffering horrible migraines, and people with depression would be fighting depression. So this is one we're going to go, phew, thank God it didn't hit us directly. But as I pull this forward, and I'm going to toggle this so you can kind of see it, because you can't see it until you toggle it. Let me stop. If you kind of look where I'm toggling it, it's a full halo. If you're paying attention, that is not all going away from us. There is still a full halo there. You can still see something going all the way around. Yes, the bulk of it will miss us, but here we go. And here's another dense. Wham. Look at there. Another dense plasma hit, and it is still moving all the way around the disk. And there's another dense WAP. We have more density coming out from that, and it is a long duration of density moving out of the sunspot. So am I right? I think, yes, we are going to see activity out of this. I think he's wrong. I think we are going to get hit. Let's confirm. Am I right? So we're going to go here. I'm going to go super slow. Okay, here's our first big CME. It's moving directly up north. But if you're paying attention and you're looking at the differential, there's still plasma moving out toward Earth. It's not big, it's not fantastic, but there's still stuff moving out toward Earth. There we have a big blast going away from Earth. Here we have one of the big full halo hits. It's off to the side. It's on our blasting out toward our oncoming limb, but we're still going to get a graze from that. There's still some activity there. Here's one of our little halo hits going down, but there's still activity. It's going under us and above us, but there's still enough in the middle we're going to get a graze. There's still wind coming out of that middle. Now, here comes a good big blast. That solid hit toward Earth. Here comes a secondary blast. Here's one of our full halos. Yep, we got a full halo coming at Earth, but the bulk of it will miss us. The bulk of it is going to be off to the side. But here comes another blast. So we're going to have two peaks. At least two peaks. Now, there's our third peak, and this one's going to likely hit, at least graze Earth. There's a fourth peak. That one's going to be a more solid hit toward Earth. And it's going to be nice and steady. That one's going to probably move up and away, but we still have plasma moving, streaming out steady to Earth. Now this one, I think we had some meteors there. That one is going to be probably a miss, but there's still some winds carrying residual stuff out toward Earth. Okay, here's our monster right here. Look at this. It is directly going under us. But look at what's in the center of that right side. That is not going to be a complete miss. It has still got enough stuff close enough to Earth that it's going to come out and graze us. There's still enough moving out toward Earth to graze us. Then we've got a big blast here that's going to come right at us. Secondary blast right straight at us. With a third one that's probably going to be a little less that grazes us. And maybe a fourth one. and maybe a fifth one. We're going to have very activity. And this is what you have to do. You have to look at all the different graphs to look at what's coming at you, and you have to put them all together in a picture. Now, looking over here at our flares, this was yesterday. We had all those long duration M-class flares. We had this nice big spike. It was an M-class, well, I think it was they have it listed as an M5, but we've had a long class C, a long class M2. Well, actually, they characterize it as 2 M-class flares in there. Let's pull this in a little bit so you get a better picture. Separate these out a little bit. So you've got 2 M-class flares here, and then it drops back down. Now you have a C and an M's, 2 M's there. You have long duration M's there. You have long duration C and M there, and another C. So you have constant flaring going on from these, probably your sunspots. When they're long duration, that means that there's particles being released with the energy. They're more likely to have flare power, CME power, and they're going to cause auroras. If it was just a quick pop, they're not going to do much. But when they're long duration, they're going to do something. All right, let's get down here. They have downgraded one of the CMEs here to an angular. But this is the one we want to look at this morning. They have more CMEs this morning going on. I want to look at, this is a super fast one that happened. It's moving up and away, but we have enough of it that it may hit Earth. Okay, the bulk of it's moving away from us, but we still may get some particles moving at us. Now, what I want you to look at this, going back to remembering what you saw on the blue and the red, I want you to put it together. Starting back here, we have a blast. Okay, the blast happened. It's 726 kilometers. And then we had a little bit, it petered out. Now we got a slow, steady wind coming out. It has some radiated particles with it. And we get a second blast. It's moving faster. It's an explosion, so it pushes it faster. And then it slows down to a radiated stream. And we have a radiated stream that's moving a little faster, maybe a little bit bigger blast. That one's moving directly north, probably won't do much for us. But then we have another blast. This one probably will do something to push it faster towards us. And then we have this one. Wham! It might be moving out away from us, but maybe it picks up those particles and pushes them a little bit faster. It's moving twice as fast as the one before it. This is the type of thing you got to look at and go, okay, I know I'm going to get hit with something. Is it going to go bigger or smaller than what they think it will? This is what I look at and I go, well, no, that's going to more than likely go a little bit bigger than what they think. Because I know I have particles that are there. Yeah, the blast is aimed away from me, but I'm still seeing enough particles there that if something comes along with a little bit faster wind, it's going to pick things up and it's going to stack it. Yeah, that's going to be a scoop shovel. It's going to make it bigger. So we get up here this morning. Here is this blast here. They're going to say it's moving directly up and away, and that is the direction of the blast. But you still have everything down here moving at you. A blast may go in that direction, but the winds at the bottom of it may push out from it. And it may give you a little boost. So we got fairly fast winds this morning. That was moving really fast. These are moving a little bit slower. So you got to balance everything you saw in the red and the blue with the speeds you see here. Could be moving as slow as 200 to 800. And that's where you take all these speeds down and you write them down and you go back to the blue and you go, well, that was moving fast. This was moving slow. And you go, okay, here's where I could have my scoop shovel. Not everything is going to be exactly as predicted. This is shoving 2D models into a 3D environment into a 2D model. Doesn't work well. It's very hard to do. But when you use all your tools right, you can say, hey, I think this is going to happen. There's millions of miles that things can speed up, slow down, run into each other, push each other faster or slower, or lots of things can happen. But you at least can make an educated guess based on your own experiences if you're out there enough times to know, okay, I can look at this and go, their guesstimates are wrong half the time. I'm going to err on the high side or the low side. So right now, they are saying tonight we're going to tip into the 5-point area. And then tomorrow, or the 25th, we're going to start peeking into the G1 4 to 5 area. I think this is conservative. I think it can go bigger, especially on the 25th and 26th. I think it could go bigger. I think we're going to continue to see this kind of activity. And going back to this, and I'm going to speed this up a little bit. I'm going to go ahead and speed this back up. We still have a very active region here that's going very actively. This is going to be out of range by this weekend. But we have these large 2 coronal holes coming in. Let's see if I can pause this and get it up here. We have, these will be earth facing probably by late Thursday, or what's today, Tuesday? Early Thursday. That means we will get their stream Saturday night into Sunday, Monday. So by Sunday, we should start seeing coronal hole streams, and anything around them could be elevated. This is going to be right in front of them. It looks like we have another good filament developing here. We've got something minor here, but we do have a sunspot region or something developing back here that's right behind it. We have a good filament here that could be eruptive. We want to keep eyes here. This could be very eruptive. This region definitely is very eruptive. And back here, I think will be eruptive. So I would look for activity to continue probably until the 28th at the very minimum. Going on to weather. It's not looking good, people. If you are down here in the Carolinas and Virginia, maybe you got a chance. Alabama, Georgia, you look like you got some clearing. Maybe down here in Illinois, you might have some broken clouds. Wyoming, the west end of North Dakota, Colorado, New Mexico, parts of Texas, you may have the ability to see these auroras if they pop off big. Oregon, Washington, California, Nevada, you might get some broken clouds that you can see the auroras. We may get some breaking in Wisconsin and northern Michigan tonight as the storm moves through. And Maine, you're in good graces there. And up here in Canada, Eastern Canada, you're looking really good. You should have a great view to this weekend or through this next couple of days. You're just going to have to watch your radar. Remember, sometimes it's a matter of a couple of miles to 30 miles. Look for those thin spots in the clouds. Get a really good radar view and dig deep. I'm not kidding you when I tell you I live on at Traverse City. We have 2 bays that are 3 miles apart. It was raining cats and dogs in a vicious storm on one bay. I drove 3 miles to the other bay and I got auroras. Sometimes it's a matter of just 3 miles that makes the difference. That's sometimes all it takes. You've got to really study your radar, talk to your weather people. If you're not a good weather person, that's what they're for. Get in there and look. Sometimes if it's high level clouds, you can still get something. That's the best I can give you. We're going to have a very brief window in the Great Lakes of maybe tonight before the rain moves in, and we've got rain for the next couple of days. It's going to be really lousy. And I'm sorry, this is the weather pattern till March. It will get better. Keep in mind, in March, we do have a big storm. Happens every year. March is always our best month out of the whole year. So you want to be prepared. How do you know when to take time off? You start watching your thing now. So this month, this is when the storms happen. So you look at February, and you back it up 3 days. And if those storms happen and at that time, 3 days earlier, then you take it to March and you back it up 3 days earlier in March. And you make that your target window. So whatever happens in February, back it up 3 days and make that your vacation time. That's the best I can give you. Aim for the corona holes because they are predictable. CMEs are not predictable. We only have 3 days warning on those. You'll have to call in sick. That's the best I can give you. They are very highly unpredictable and they can happen. And, some of these things like a flare can, if it's moving really fast, can hit Earth in as little as 8 minutes. Some of these CMEs take 36 hours to hit us. Some of them only take 18 hours. It just depends on how fast and how big the explosions were and the flares were and how fast they're moving off the sun to know how fast they're going to hit Earth. And it's highly variable. So it's very hard to predict how fast and when something's going to hit. So you want to aim for the corona holes and use your 27-day forecast. If it happens in February, the month before, you back it up 3 days. And that's your window. Typically, you get the corona holes will at least elevate it to a 5, typically, and activity normally is pretty good around corona holes, and you have the best chance of getting a big pop off around a corona hole. So that's my best guess to give you. Good luck hunting. Hope to see some good pictures.